Alright folks, today we're going to be talking about mole conversions, putting it all together. This is the last one out of all 5 worksheets. Right? It's only 2 slides, so hopefully it'll go pretty quickly for you. We have a container filled with 10 grams of gaseous carbon dioxide. So when I look at carbon dioxide, I should know that carbon dioxide is 44.009 grams per mole. I'm not going to worry about that because I'm assuming you know how to do that by now. Right. Now, what we have is we have CO2 when we have carbon dioxide. So you really need to think about what carbon dioxide is. So if I have 1 mole of carbon dioxide, I'm going to have 1 mole of carbon. But 1 mole of carbon dioxide is made up of 2 moles of oxygen. So I need to understand those ratios between carbon dioxide, carbon, and oxygen. So, if I have 10 grams of gaseous carbon dioxide, let's go ahead and figure out how many moles I have. If I have 10.0 grams of carbon dioxide, and I want to convert between grams of carbon dioxide and moles of carbon dioxide, for every mole, that is 44.009 grams. When I do the math, I come up with 0.227 moles of carbon dioxide. Now, what you need to think about are those ratios. If I have 0.227 moles of carbon dioxide, how many moles of carbon is that? Well, this tells us that we must have, that's a therefore, by the way, 0.227 moles of carbon. And we have to have twice that much of oxygen. So if I take 0.227 and multiply by 2, I get 0.454 moles of oxygen. So that ratio, that is key to being able to figure out this problem. Alright, so let's look at problem A. Now that I've gotten that far, I should be able to do problem A. Problem A says, how many atoms of carbon are in the container? Well, if I have 0.227 moles of carbon, then I should be able to go from moles of carbon to atoms of carbon. And for every mole of carbon, there's 6.02 times 10 to the 23rd atoms. And that will give me 1.37 times 10 to the 23rd atoms of carbon. Well, how about part B? Part B says how many atoms of oxygen are there? Well, B, before I even do it, I should be able to look at this number and predict that it should be twice that number. So it should be 2.74 times 10 to the 23rd. But let's see if that's actually what we come up with. We start with 0.454 moles of oxygen. And I have to go from moles of oxygen to atoms of oxygen. And atoms of oxygen are 6.02 times 10 to the 23rd. If I actually multiply the thing out, I will find out that I get exactly what I suspected. 2.74 times 10 to the 23rd atoms of oxygen. So my third question is, how many grams of oxygen do I have? Well, I know how many atoms I have. I know how many moles I have. If I know how many moles I have, which is 0.454 moles of oxygen, I should be able to figure out how much the mass is. Well, I know that 1 mole of oxygen weighs 15.999 grams. So if I go and multiply that out, I come out with 7.27 grams of oxygen. And that's my answer to problem 1. Let's go on to problem 2. Problem 2 is very similar to problem 1. We again are dealing with gaseous carbon dioxide, but this time we're dealing with liters of gaseous carbon dioxide. We're assuming that we are at STP. That should be in the problem, but it's not. Alright, so we start with 15.0 liters of CO2 gas. And we want to convert that to moles, because we always like moles. That's the way we figure things out. And we know that there are 22.4 liters of CO2 gas in 1 mole of CO2 gas. So if we multiply that out, we come up with 0.670 moles of CO2 gas. Well, again, similarly to our logic last time, that tells us that we have 0.670 moles of carbon, because that's what makes up CO2. But we have to have twice as much oxygen. So we have 1.34 moles of oxygen. Okay, now using that information, we should be able to solve the problem that we have up at the top. How many atoms of carbon are in the container? Well, carbon, we have 0.670 moles of carbon. And we're going to get rid of moles of carbon. And we're going to go to, what are we going to? Atoms of carbon. And that's 6.02 times 10 to the 23rd atoms of carbon in 1 mole. When I multiply that out, I find out that I get 4.03 times 10 to the 23rd atoms of carbon. What about oxygen? Well, it should be twice that. It should be 8.06. At least that's what we predict. Let's see what happens. We have 1.34 moles of oxygen. And we're going to convert from moles of oxygen to atoms of oxygen. And that's, again, 6.02 times 10 to the 23rd atoms of oxygen. We multiply that out, and we get 8.06 times 10 to the 23rd atoms of oxygen. What about part C? Part C is asking us for grams of oxygen. Well, we know how many moles of oxygen we have. It's right there. So if we have 1.34 moles of oxygen, and we want to get rid of moles of oxygen, and we want to go to grams of oxygen, well, we know from the periodic table that oxygen weighs 15.999 grams per mole. If I multiply that out, I get 21.4 grams of oxygen. That's it, folks. If you have questions, please see me in class. That's the last Worksheet podcast. Have a wonderful day, and I'll see you in class.